guys, welcome back to our channel. Today we are going to see how ARP works in the L3 scenario. ARP means Address Resolution Protocol. Already we have a video posted in our channel regarding how ARP works in the L2 scenario, that is within the network. Now we have considered a scenario where client 1 wants to communicate to client 2. Client 1 and client 2 are in different subnets. So what is meant by subnet? Subnet is something which is the logical division of one network. If you consider here, client 1 is in 192.168.2.2, which is 2.0 network, whereas client 2 is in 3.0 network. Basically, they are a division of 192.168.0.0 network. Now, to connect these two subnets, we need a router. So the router is going to be the default gateway for this client 1 and client 2. So to demonstrate subnetting in an easy way, consider we have north facing apartments and south facing apartments. Consider these two are in two subnets. And we have a security gate which is going to connect these two subnets. That is going to be our router, and IP address is going to be the flat number. So then what is subnet mask? Subnet mask is a number that determines which part of an IP address belongs to the network and which part belongs to the devices within that network. So consider a subnet mask where we have 2.255.255.255.0. If you convert this into a binary representations, so whatever the ones which is going to be the networks, that is we are going to have 2 power 24 networks, and the remaining zeros is going to be the number of hosts, that is we have to do a 2 power. So 2 power 8, but here there is one thing, we have to do -2. Why this -2? Because the first address will be going to be the network address, via which you will be distinguished between each network. And the last address is going to be the broadcast address. Now let's come into our scenario. So now client 1 wants to communicate to the client 2. So how it will know whether it is going to be the same subnet or different subnet, how it will identify that? Because if it is in the same L2 network, you can easily communicate it. We don't require the router. It doesn't require to send it to default gateway also. Now let's take the client 1's IP address, convert it into a binary representation. So take the subnet mask, do the binary representation of it, do a bitwise AND. Bitwise AND is nothing but if both the bits are 1, we will mark it as 1, otherwise it is going to be 0. If you convert this, you will get the network address as 2.0, and for client 2 it will be 3.0. Now we have understood, okay, they both are in the different network. So what client 1 will do is, it will send it to the default gateway. But wait, how will you send it to the default gateway if you doesn't know the MAC address? We know only the IP address of the default gateway, right? We know the MAC address of the default gateway. In that way only you can actually send the packet in a physical medium. Because IP address comes into the network layer. Before that, the lower layer, we have a data link layer, right? And physical layer. So these layers will understand only the MAC address. We have already covered the different layers of the TCP IP model in our previous videos. So now let's see it has the MAC address of the default gateway or not. Let's execute the command ARP -a. Our default gateway is 192.168.2.3. It is not there in our cache. So now it has to be resolved. So that's where ARP comes into picture. Now client 1 will send a ARP request with the source MAC as its own MAC address. Destination MAC will be the broadcast, because now it doesn't know the MAC address of the gateway. Source IP will be its own IP, and the destination IP will be the default gateway. Now a router will capture this ARP request and it will send a ARP reply. So in the ARP reply, actually it will be sending with its own MAC address. So now client 1 will comes to know about the MAC address of the default gateway. Once the ARP resolution has been done, now the actual ICMP will be gone through. ICMP has been covered. So now in the ICMP request, actually it will be filled the MAC address of the default gateway. Okay, now router has got the ICMP request. So it has found that the destination IP will be 3.2. So now where it will send to reach the client to? We have a routing table. So the routing table will contains what are the routes that is connected via which interface. So now we have directly connected two networks, 2.0 and 3.2. And the 2.0 network is connected via the gigabit Ethernet 0 and 3.0 is connected via gigabit Ethernet 1. Now router would have figured out, okay, it has to send it to the gigabit 1 interface. Now again one more thing. It doesn't know about the MAC address of the client 2, right? Now again ARP request will be done. Now it will send the ARP request and the client 2 will send a ARP reply back with its own MAC address. So now in the actual ICMP request, the destination MAC will be replaced with the client 2 MAC. Hope you have understood the purpose of ARP resolution in this scenario. Please do like, share and subscribe. Thank you.